Hey everyone, Emma here from Cyberbrief, and today we're talking about something fundamental to network security, topologies. This isn't just dry networking theory. Understanding topologies is key to securing your digital world. So let's dive in. First up, let's talk about what a topology is. Think of it like a map that shows how all the pieces in a network are connected. It's like figuring out the relationships between the stars in the sky or the roads in a city. We've got two main types of topologies in networking, physical and logical. Let's start with the physical. Physical topology is all about how the actual hardware is wired or connected. Imagine you're setting up a network in your home or office. You take cables and plug them from your computers into a switch. That's a physical connection. You can picture this as a star where the switch is the center and each cable from a computer is like a point of the star. But it's not just about the cables. Physical topology also deals with how data is sent across these connections. For example, traditional cables use electrical signals, fiber optics use light pulses, and wireless uses radio waves. Each method is a different physical topology because they physically move data in unique ways. Think about how a signal might weaken over a long Ethernet cable versus traveling almost instantly through fiber. Security implications of physical topology. Cable management. Poorly managed cables can be a physical security risk. Someone could easily unplug or tamper with them. Use cable management solutions to keep everything tidy and secure. In a business environment, label cables to quickly identify anomalies or unauthorized changes. Physical access control. If your network equipment is in an unsecured room, anyone could walk in and mess with it. Lock your server rooms, use surveillance, and control who has access with keycard systems. Consider biometric access for critical infrastructure to add another layer of security. Redundancy. A single point of failure, like a central switch in a star topology, can bring down the whole network. Implement redundant paths or use a mesh topology to ensure if one path fails, data can travel another way. For example, in data centers, multiple switches might be used in parallel to avoid downtime. Environmental controls, temperature, humidity, and power supply can affect hardware. Ensure your network environment is controlled to prevent hardware failures. In places like server rooms, have backup power supplies and climate control systems to maintain optimal conditions. Now let's shift gears to logical topology. This is more about how data gets from point A to point B regardless of the physical setup. Logical topology is like the language your network speaks. Computers communicate using binary, that's ones and zeros. It's the basic language of computing, where everything is either on or off. Logical topology deals with how these ones and zeros are arranged to send messages. So while physical topology is about the roads, logical topology is about the traffic rules. Security implications of logical topology. Data encryption. Even if someone can intercept your data, if it's encrypted, they'll only see gibberish. Use encryption for both data at rest and in transit. For instance, use IPsec for VPN tunnels to secure traffic between sites. Network protocols. Protocols like TCP/IP dictate how data is sent. Misconfigurations or outdated protocols can be exploited. Regularly update and secure your protocols with authentication and integrity checks. For example, use SNMPv3 instead of earlier versions to avoid sending network management data in clear text. Segmentation. Logical segmentation through VLANs or subnets can prevent an attacker from moving freely across your network. If one segment is compromised, the damage is contained. In a corporate network, you might have separate VLANs for HR, finance, and guest Wi-Fi. Traffic monitoring. Use tools to monitor network traffic for anomalies. If data is suddenly going where it shouldn't, you might have a logical breach. Tools like NetFlow can help you see patterns in traffic that might indicate an attack. Understanding both types of topologies is crucial because they help us see where our network might be vulnerable. Physical risks could be someone unplugging a cable or cutting a fiber line. Logical risks might involve someone intercepting or misdirecting that stream of ones and zeros. Here's where it gets interesting for security folks like us. If you know how your network is physically laid out, you can better secure the hardware. But knowing the logical flow is key to protecting the data itself. For instance, if you know your network uses a star topology, you know that if the switch fails, everything connected to it goes down. So you'd want to secure that switch like it's the crown jewel of your network. Secure the switch. Use strong authentication, disable unused ports, and implement port security to prevent unauthorized devices from connecting. For example, only allow specific MAC addresses on each port to prevent rogue devices from connecting. Regular updates. Keep the switch's firmware updated to patch vulnerabilities. An outdated switch can be an easy target for an attacker who knows about known exploits. On the logical side, if you understand how data is formatted and sent, you can spot when something fishy is happening. Like if data isn't following the expected path or if there's unusual activity in the binary conversation. Intrusion Detection Systems, IDS. Set up IDS to alert you when traffic patterns deviate from the norm. For example, if there's a sudden spike in SSH login attempts from an unusual IP, your IDS should flag this. Firewalls. Configure firewalls to control what data can move where, based on your logical topology. Implement rules that only allow necessary traffic, reducing the attack surface. But let's not forget, topologies aren't just about how things are connected. They're about how communication works. For example, in a physical topology, we might talk about signal degradation over long distances or interference. In a logical topology, we might discuss protocols that dictate how data packets are structured or routed. Practical steps for secure topologies. Physical topology. Use tamper-evident seals on cables and hardware. This can deter tampering and help you detect if someone has tried to access your network physically. Regularly audit physical connections to ensure no unauthorized devices are plugged in. Walk through your network spaces looking for anything out of place. Logical topology. Implement VLANs to control traffic flow, reducing the risk of lateral movement by attackers. For example, isolate your IoT devices from your critical business systems. Use access control lists, ACLs, to define who can talk to whom within your network. This can prevent unauthorized access to sensitive areas of your network. Now let's talk about why this matters for security. Your network's topology can influence how an attack is carried out. For example, if an attacker knows your physical layout, they might target a central switch. If they understand your logical topology, they could exploit your communication protocols. Attack surface reduction. By understanding your topology, you can reduce the areas where attackers can strike by securing critical points or limiting communication paths. For instance, close off unnecessary ports on switches to reduce where an attacker can enter. We also need to consider how physical and logical topologies interact. You might have a secure logical setup, but if someone can physically access your network equipment, all that security can be bypassed. Integrated security. Combine physical security measures with logical ones. For example, if you have a secure logical setup, ensure physical access is equally controlled. Use network switches that can lock down ports if unauthorized access is detected. Let's dive into some practical examples. If your network uses a ring topology physically, where each device is connected to two others forming a loop, you'd need to think about how to prevent network failures from propagating around the ring. Logically, you'd need to ensure your data packets don't get stuck in this loop. Redundancy and failover. For physical rings, implement protocols like Spanning Tree Protocol, STP, to prevent loops. Logically, use routing protocols that can detect and avoid loops. For example, OSPF can dynamically adjust routes to prevent data from looping. Or take a mesh topology, where devices are interconnected in multiple ways. Physically, this can be more robust, but logically, you need to manage where data goes to avoid congestion or security breaches. Path optimization. Use dynamic routing protocols to find the best path for data, reducing congestion and improving security by avoiding compromised routes. Protocols like IGRP can help with this by choosing paths based on multiple criteria, not just shortest path. Understanding topologies also helps in planning network growth. If you need to add more devices, knowing your topology helps you decide where to connect them without compromising security or performance. Scalability. Plan for growth by considering how new devices will affect both physical connections and data flow. For instance, adding a new server might require not just physical space but also careful integration into your existing VLAN structure for security. And let's not forget physical security. While we often focus on digital threats, someone could just walk into your server room and mess with your hardware if it's not locked down. So, physical security matters even if it's not our daily bread and butter. In cybersecurity, we deal a lot with logical controls like firewalls, encryption, and access controls. But remember, securing your network isn't just about software, it's about the whole picture, including physical elements. So, why should you care about this? Because knowing your network's topology means you can predict where attackers might strike, how they might do it, and how you can stop them. It's like being a detective in your own network, always one step ahead. And that's what we're all about here at Cyberbrief, making you into that network detective. If you're into this, stick around because I've got more content that'll keep you on your toes. Whether you're a pro or just starting, we're in this together, turning you into a cybersecurity expert one episode at a time. Want to continue learning the secrets of the pros? Like, subscribe, and ring that bell for more cyber adventures. Until next time, keep learning, keep questioning, and stay secure, my friends.